Hi guys! So today I wanted to talk a bit about inductive reasoning. Inductive reasoning views premises as supplying strong evidence for the truth of a conclusion. And we say strong because unlike deductive reasoning where the conclusion is guaranteed by its premises, the conclusion is not certain. That does not mean that inductive reasoning is less useful because it is less certain. It is simply a means to assess many problems in the world that cannot rely on deductive reasoning alone to resolve, of which there are many. And inductive reasoning is used in mathematics all the time. If you can prove one case, you can prove them all in theory. Inductive reasoning relies on all of the premises being true most of the time. So while there may be an outlier case, one would attempt to draw a rule from the results and apply that to other applications. Since computer science relies heavily on mathematics, it uses very similar reasoning. Take the problem of representing integers in a computer, for example. With binary, it was quite tricky to come up with a system that included negative numbers without introducing other problems like multiple zeros. You don't actually need another number for -0, go figure. It took some time for anyone to come up with the idea of two's complement, a system that allowed for easy conversion from positive to negative integers. Once people understood the issues that this system addressed in dealing with integers with little to no drawback, it was adopted with earnest over previous methods. The idea of two's complement is that given any binary number, you can flip the bits, that is, change the zeros to ones and the ones to zeros, and add 1 to result in the negative of the same number. The outcome is each number, within a bounded range at least, has a corresponding negative number with no duplicates or overlap. Two's complement is a great example of how effective inductive reasoning is in the computer science field. There are so many general rule of thumb ideas like this used in computer science that are founded only in their consistency and results. The best code wins, so to speak. And like mathematics, there is work that can show why certain pieces of code work better than other pieces of code. We calculate the time a program takes to execute, the resources it needs to do so, whether it slows down other aspects of the program or the computer itself, heck, whether it compiles and runs at all. And this inductive reasoning allows room for new ideas if they are good enough, which is terribly exciting, don't you think?